let's graph the equation of the tangent line, or the derivative, for this red graph here, in this first little graph that I put here. So what they want me to do is they want to find at every single point what the slope of the tangent line is. Well, if it's a line, the slope of the tangent line is just the slope of the line itself. And if it's a 45-degree angle here, that means it goes over 1, down 1, which means the slope is -1. M equals -1. So your tangent line here, I'm going to do an open circle here. We'll use blue for the tangent line, light blue. So there's my open circle, and there's the slope of my tangent line for all the points starting at 0, not including 0, and going to the right. For this 30-degree part over here, 30 degree, remember 30 degrees from your unit circle. In fact, you could draw a triangle if you wanted to. If that's a 30-degree triangle right there, I can put another 30-degree triangle right next to it. This is how I prove the unit circle works nicely. And that would make this 60, 60, 60 everywhere. So these sides right here, these lengths, if these are 1, then this right here, this whole thing is 1, which means this right here is 1/2. And using Pythagorean's theorem, this would be √3/2. So this distance right here is √3/2, and this distance right here is 1/2.
X equals 0.
So what's the slope?
Root. You got an x equals 2 and an x equals -1.
Rise over run.
This is
Well, you can think about going up 1/2. That's the rise over, and the run would be -√3/2, which means -1/√3, which is -√3/3. Is that bigger than or smaller than 1?
the same thing. Fx.
Smaller.
It is smaller than 1. It's below, I should say -1. Is it below -1 or above -1?
The same thing as we did in the last one.
Root square root of 3 is smaller than 3. Oh, I said that wrong. Well, you probably said it right. Let me start over. Is the negative square root of 3 over 3, where is it in relationship to that blue line that we have right there on the graph? Is it above the blue line or below it? Because you know it's going to be a constant line. It's going to be a horizontal line. -√3/3 is like somewhere in there. Because square root of 3 is 1 point something. So it's like -1/3-ish, something like that. So there's the graph of the derivative for that red line that you had originally. Let's try this next one. Again, we're trying to graph. Now the graph is blue, and I'm going to, no, let's make it red. Let's make the graph red to be consistent. The graph does this. And that's the original graph, and in blue I'm going to graph the derivative, and with green I'm going to look at the tangent lines. So the tangent line at all these points, imagine drawing a line in at every point that just touches it. What's happening? What's the slope of all these lines? So this is what I'm doing. Tangent lines, tangent lines, tangent lines. Oops, tangent line. And what you can see happening, let me take my blue, this is my derivative, and I'm going to start plotting points. The slope of this line right here, this last one, is really close to 0. In fact, the further this red graph goes to the right, the closer it gets to 0. But the slopes of all these lines, notice, are negative slopes because they're slanting down from left to right. So it's below the x-axis, but it's getting closer to 0. That's what's happening over there. And right here, that point has a vertical. There is no slope. The tangent line is a vertical line, so the slope, there is no slope for a vertical line, and so there's a vertical asymptote right there. And you can see that the slope of the lines right before that are going to be as steep as possible, and theoretically it's going to -infinity because those are negative slopes. They're negative numbers. And then on this side, same thing. Very steep slopes right here, the tangent line. So it goes toward negative infinity when it gets closer to the point 0 from the left. But then as it goes up
There we go.
or to the left towards negative infinity, the slopes flatten out. If you can imagine, they're going to become flatter and flatter and flatter. So again, on this side, the derivative is approaching 0 as x goes to negative infinity. So this blue line right here and that blue line right there are the graphs of the derivative of that original red line. Let's do one more. All right, last one. Here's my red graph, and I'm going to use again green lines. I'm going to use really light green lines this time so I can draw lots of them in here. What's the slope of the tangent line way over here? Right there. There's a tangent line, 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 there's a tangent line. On this side, tangent line there, tangent line there, tangent line there. Obviously there's an infinite number of tangent lines, but what is the slope of these tangent lines way over here on the left as it goes toward infinity? First of all of these slopes on the left of 0, all of those are positive slopes. They're positive. The slopes of those tangent lines are all positive, but it's getting flatter and flatter the further left you go. So your graph, doing the graph in blue, as you get closer to negative infinity, as x goes toward negative infinity, the slope of the tangent line gets closer and closer to 0. But as it gets closer to 0, notice there's a point right there. So there's going to be a vertical asymptote that won't be crossed because there's no derivative right there. Get rid of that thing, but there's no derivative at 0 because it's a point. But the slope of those tangent lines is getting steeper and steeper, so it's becoming a bigger number, so it's doing this. On the left side, it's similar to that, but all of these lines have a negative slope. So as x goes to positive infinity, the tangent line, the slope of the tangent line is getting closer to 0. It's never going to reach 0. And as it gets closer to 0 from the left, the slopes of those tangent lines are becoming large negative numbers, like that. So there's your graph. One other concept you're going to learn soon is concavity. And so you can tell that this red graph, this original red graph, was concave up. See how that's concave up right there? And a graph that's concave up, has to do with double derivatives, which you're going to get to at another point, but I guess I don't want to get into that right now with you. That's enough for now.